Hello everyone. Today we are going to see the conversion of 1-chloropropane to propane 2-ol benzene, and this is our electrophilic substitution reaction by the method of Friedel-Crafts Alkylation. Starting with our starting material, that is 1-chloropropane. If you see, 1-chloropropane belongs to the primary halide structure. The chlorine is attached to the first carbon. Now this propane, 1-chloropropane, going to react with the aluminium chloride. Now this aluminium chloride is a Lewis acid. The Lewis acid is, as we all know, the theory of the acid base, it is one which is deficient of the electron. So this chlorine going to shift on this aluminium. Now this shift takes place when the chlorine takes away the electron pair which was shared and going to attack on the aluminium, thus lead to the formation of primary cation, which is propyl 1-allium, and your aluminium chloride complex with the completed octet state. Now when you talk about propyl 1-allium, it's a carbocation primary state. Now this needs to be stabilized first. Okay, so when during this stabilization process, the hydrogen going to shift on this carbocation. So that is the conversion from the prop 1-allium to the prop 2-allium by the hydride shift of the hydrogen proton from the alpha carbon of the carbocation to the carbocation first carbon, lead to the formation of secondary carbocation, which is prop 2-allium. Just now I explained to you how can propyl 1-allium can be converted to propyl 2-allium. Now during this process, the hyperconjugation theory comes into picture. No bond resonance. Resonance, we are all aware, there will be a delocalization of electrons. So over here there are sigma electrons which play important role, and the sigma electrons come from the carbon and the hydrogen bond of the propylium ion. Now this carbon belongs to the alpha carbon. Now this alpha carbon is with respect to the unsaturated carbon, or maybe by the empty orbital, or the carbon with the p orbital with the unpaired electron. Generally it is radicals. Okay, now this propyl 1-allium, here we can see this is your carbocation first carbon, so it becomes primary carbocation. Over here there are the alpha hydrogens. Now these alpha hydrogens are 2 alpha hydrogen. With respect to these structure, this structure we can say there will be formation of 2 resonating structure, because there will be 1 proton loss. When there is 1 proton loss, there will be electrons over here which will be shared by this carbocation, and this kind of structure can be generated. When we take this hydrogen if it leaves, there will be a formation of double bond. It will give me this type of structure. Okay, so there are 2 resonating structure for this propyl 1-allium structure. When we do the hydrogen shifting from alpha hydrogen to this carbocation, there will be the formation of the secondary carbocation. Now this secondary carbocation is known as prop 2-allium. When there are 3 carbons and the second carbon will get a positive charge, again there will be a delocalization. Now this kind of delocalization occurs from the neighboring 2 alpha hydrogens. These one set of alpha hydrogens are there, these are the another alpha hydrogen. So these all 6 alpha hydrogen going to displace over here and lead to the formation of double bond. When the hydrogen, say this one, leaves, the electron which are left behind on the carbon will be shared with the second carbon and lead to the formation of this resonating structure. Likewise, if this green one going to leave, the proton, and lead to the formation of second carbon. So the resonating structure is formed with a sigma 2 pi bond. Over here, if the red proton leaves, again the electrons are left behind and it will be shared by this carbon with positive charge and going to give you again one more structure with the pi bonds. So altogether till now we have survived with the 3 structures after resonance. This will be the 4th structure which comes from this alpha hydrogen, second alpha hydrogens, second pair of alpha hydrogen. Over here again the blue color proton going to leave and the carbon left behind with the electrons which is going to share with the second carbon and thus form this structure. Likewise, there are 2 more structures because of this hydrogen and this hydrogen. Thus, it leads to the formation of total 6 resonating structure. Thus, we say that if there are more resonating structures, the greater will be the stability of that particular structure. Hence, we conclude that probe 2 ileum is much more having stability better than your probe 1 ileum. Probe 2 ileum going to react with our second reactant, that is benzene. This we all know that benzene consists of the pi electrons in the p orbitals, thus forming the conjugated double bonds. Now one of the double bond going to be break down and that going to take the electron from this carbon on this carbocation. It will attack on this carbocation, which is secondary carbocation, and lead to the formation of propane 2-ol benzene. Thank you.